In class today, Thursday the 20th, I showed that this series equals this. And we started with this series. We integrated it, and that's how we got this series. But I'm not going to go through all the details because we did it in class. But we started with this series, which converges for absolute x less than 1. And so that means that this series, this equality holds on at least, sorry, let me make that clearer, on at least, for at least where x is, absolute value of x is less than 1. In other words, the interval -1 to 1. So we know that that's true here. But how about when x is equal to -1 or x equal to 1? It turns out when you integrate a power series, you're adding this k plus 1 term in the bottom, and that can increase convergence. I mean, sometimes taking derivatives does too. So anyway, I wanted to go over this again. So we showed this in class. So we plugged in x equal 1 into this series. So I get -1 this, and we wrote it out, and we got this alternating harmonic series. So it's an alternating series, and we showed that the terms decreased. Pretty clear to see that 1 is greater than 1/2 is greater than 1/3, and that limit ak was equal to 0. This limit is going to go to 0 with k. Sorry, it's a limit k goes to infinity. Okay, so then we know that this series converges by the alternating series test. So that means that this series converges when x is equal to 1. So now the interval of convergence is at least, cross that out, -1 to 1 closed. Okay, so what I'm going to do in the back, I'm going to test x equal -1. So let's see what we get. So we'll keep that up here just so you can kind of look at that. Okay, now I'm going to plug in x equals -1 into, sorry, let's get a little bit more room. Yep, this series. And I get summation k is equal to 0, -1 to the k, -1 to the k plus 1. And if you work this out, you're going to get that this is equal to -1 over k plus 1, starting at 0. And I'll show why that is. This is going to be -1 to the k plus 1, using that exponent rule over k plus 1. This is going to be equal to k is equal to 0, -1 to the 2k, get those together, times -1 to the 1, that one, over k plus 1. This is always positive, so this becomes this series -1 to the k plus 1. Or you can just see it from here. This is negative when k is odd. This makes it negative when k is even, so it's always negative. So anyway, so this series is equal to -1 plus -1 plus -1 plus -1, so on and so on, and that diverges to -infinity. So here we get a big divergence, the scarlet D. So we have that this series, the given series, so to speak, converges on -1 to 1 because we started by integrating this series, which converges on -1 to 1. We know that it converges at x equals 1. Well, that's what we showed here and in class. But it diverges on, but it diverges at x equal -1. So the interval of convergence equals -1 not included to included. In other words, this equals natural log x plus 1 on this interval right here. Okay, so I'm going to show this a different way. I'm going to just pretend I'm going to start with this series. We're going to forget where it comes from. I'm going to use a different way to show that this is the interval of convergence. So that'll be in the next video.